Hey guys, my name is Stevie Mack, and today I'm going to teach you how to solve a triple integral. So coming over here, we have a triple integral that has the bounds 1, -1, 0, negative square root of 1 minus x squared, and 0, square root of 1 minus x squared minus y squared, 2x squared times y, dz, dy, dx. Okay, so how to solve this problem is that since there's this function right here is a spherical coordinate, spherical equation. So to do this, we're going to have to change all these bounds. Everything's going to have to change. So to change a bound, you have to make a graph. Well, not a graph, but something like that. A plot, graph, plot. What is it? A graph. We're gonna make a graph. And then so we have y to x, but x has 1, -1. So we gotta put 1 and then -1 right here. And since dy is a equation for a circle, and since this is negative, it'll be the bottom half of this circle. So it'll be from -1 to 1, and for a circle coordinate, we have to use theta. So it'll be from pi theta to 2 pi. And then we have to make a graph for a spherical equation. We make a z graph. So it'll be z, then z over x. And then this middle part will be 0 because that's where it starts. Okay, and then it will expand outward this way for to graph a spherical coordinate in the equation. So it'll be like this. So it goes from 0 to pi over half, which will be 0 to 5 pi over 2. Okay, so now that we have that, we now make new triple integrals that we found. So for the bound for x, it will be 0 pi over 2, and then for y, it will be pi to 2 pi, and then for z, it'll just be 0 to 1. And then for the x squared, it'll be rho squared sine squared of 5 times cosine squared theta. This is just for x squared. Now for y, it will be rho sine phi sine theta. And then we have to finish it out with rho squared sine phi d rho d theta d phi. Okay. Now next step is we combine all this. So for 0 to pi over half, it will be anything that's with a phi. So it'll be sine squared phi times sine phi, and then sine phi again. So it'll be sine to the 4th power phi d phi. Then we take the second one, which is pi to 2 pi, and this will be for theta, and this will equal cosine theta times cosine squared theta times sine theta, which will be this. D theta. Then next we have the rows. So we have rho squared, rho again, then rho squared again. So all that will be 0 to 1 bound, row to the fifth. Even though this looks like an E, but we can call it E2 because I'm not really good with letters. I'm math, not writing. Then we set that to D row. Okay. So from 0 to power of 2, sine of the fourth power is understood to equal 3 pi over 16. And for the next step, we're gonna have to use a term from Calc 2, which is U substitution. So we have to use U substitution for this one. And then what we're going to substitute is cosine squared. So U will equal cosine theta. And then, so we take the derivative of cosine theta, and then du will equal negative sine theta, d theta. And so we can't really have a negative right there, so we just move the negative out front, so that'll be negative that, and then get rid of that. And then cosine pi will give you negative 1, because we're substituting pi in for where cosine theta, where theta is. And then 2 pi will equal 1. And then for this one, to solve this one, you have to substitute 1 in for where rho is, so and take the antiderivative, which will be, let's take right here, will be 1 to the 6th power, because, well, 1 to the 6th, this will still be 1, minus 0 to the 6th over 6, which will just give you 1 over 6. That's how you solve a integral from row to the fifth. Now we can set this. We can solve. This will be 3 pi over 16. And be careful with this one, U substitution. These will now be your new bounds for pi to 2 pi. So pi to 2 pi now changes to negative with the bound of negative 1 to 1, with U substitute back in for cosine squared is, which we will put U, so this will be U squared du times 1 over 6. Now to solve this one is the same thing as solve this one. You plug in 1 for where the U is, so be 1, and then use that 2 and bring it and add it 3, and then bring that 3 down. So it'll be 1/3 minus the second one, which will be a negative 1/3, and then that will just be negative 1 with a negative 1 outside, which will be 3 pi over 16 times negative 2/3 times 1 over 6. And this simplified will give you just negative pi over 48. This is how you solve a triple integral using spherical coordinates, and that's all I have for you today.